Let's learn how to convert polar coordinates to rectangular coordinates. Okay, uh, let's say we have a random point somewhere in space, and we know the polar coordinates of that point. In other words, we know r and we know theta for that point. Remember, r is this distance from the origin. We know that, and theta is the angle from the positive x-axis. Suppose we know both of those things, but we want to know x and y. That's the part that we want, right? We want to convert from polar coordinates to good old x and y, Cartesian or rectangular coordinates. Okay. Well, I think that you guys are pretty well trained by now to recognize that right triangles are going to come to the rescue, and particularly SOHCAHTOA, right? So we want to know x. That's how far this point is from the origin in the x direction. That's this distance right here. That's x. We also want to know y. Okay, if the right triangle wasn't obvious to you a second ago, now it is. We've got a right angle there, and we can actually get a formula for x and y in terms of r and theta using our basic understanding of trigonometric ratios and SOHCAHTOA, right? X. Which trig function corresponds with x? Cosine. Cosine of theta equals the adjacent side over the hypotenuse, x over r. The sine of theta, opposite over hypotenuse, y over r, because we know that sine always corresponds with y, just like before when we were learning the unit circle and all this stuff, right? But since we want to know x and y, we probably should take these formulas and solve them for x and for y. So this one would turn into, if I multiply both sides by r, what do I get? X equals r cosine theta, and this one becomes y equals r sine theta. Those are the formulas for converting polar to rectangular. Okay, so definitely write that down. That'll be very helpful for you. Okay, since you have formulas, why don't you give these examples a try without me, and I'll do them in a moment. Okay, so why don't you pause the video and see if you can convert these polar coordinate points into rectangular coordinate points using these formulas that we just wrote down. Okay, so give that a try, and you can unpause the video when you're ready. Okay, now before I show how to do these problems, I challenge you, if you actually did them, I challenge you to be courageous and brave enough to post your answers in the comment section. Okay, +1 respect to anybody who has that much courage to post your answers. You don't know if they're right or wrong yet, post them right now in the comments. +1 respect, even if you're wrong. I respect you for having the courage to do so, and that'll give me some feedback for how this video is going. A little bit more interaction that way, okay? Okay, hopefully you've done that. Now let's do these. Here's the rectangular coordinates. There's my r, there's my theta, right? I want to convert those into rectangular coordinates. I've got my formulas. I can find x. Well, actually, before I even do that, let's draw a quick picture. Where is this point? Pi over 3 is my angle, and 5 is my radius. So pi over 3, that's 60 degrees. Okay, so there's pi over 3, and I'm at 5. There's my point, and I want to know the x and the y, the x and the y of that point. Okay, if you know your special right triangles, you could probably figure it out, but the formulas are so nice. X equals r, which is 5, cosine of theta, which is pi over 3. Okay, and if you know your trig, you know your unit circle, you know that the cosine of pi over 3 is a half. So it's 5 times a half, which is 5 over 2. Now let's calculate y. Y is going to be 5 sine theta. Oh, which I didn't put in theta. Let's put in theta as pi over 3 here. Okay, so that would be 5. Sine of pi over 3 is going to be root 3 over 2. Okay, if you don't know how I'm getting that, by the way, go back to your unit circle or draw it and draw your reference angle and then use this, what you know about special right triangles. And when I multiply this, there's no real way to simplify it other than to put that 5 on the numerator there with the 3, and I get 5 root 3 over 2. So what's left is to write it in Cartesian coordinate form, x and y. Okay, so I know this x value is 5 over 2, and I know this y value is 5 root 3 over 2. Those are the rectangular coordinates of that point. Okay, now I'm going to do a quick double check. I know this is a 30, 60, 90 triangle. My short leg should be half the length of my hypotenuse, 5, and half of 5. We're good. And then my long leg should be square root of 3 times my short leg, and it is. So if you know the proportions of a 30, 60, 90 triangle, then you can double check your work there pretty easy. Okay. Part B. Only thing different here is we've got a negative r value. That's okay. The formulas still work. I'm going to quickly graph where we are. 135, that is going this way, but our radius is negative 2. So we go backwards 2 when our radius is negative. So that's our point, and our angle is 135 to there, right? But we go 2 backwards, and there we're there. So that's our point. I want to know what's the x and what's the y. Our coordinates, our formulas still work. Let's use them. X equals r cosine theta. Negative 2. Cosine of 135 is negative root 2 over 2. Hey, look at that. 2 divided by 2 is 1. Negative times a negative is a positive, and we just get root 2. So that's our x. And let's do y. Negative 2 is my r. Sine of theta is 135. Okay, oops, off the camera there. Sine of 135 is positive root 2 over 2. So I get negative 2 times positive root 2 over 2. 2's can't divide, and then we get negative root 2. So, oh yeah, y is a negative value. I can see that pretty obviously. So negative root 2. So here's our coordinates, root 2, negative root 2. Hey, if you got both of these right, nice work. I'm proud of you. Good job. Mr. Troll, seal of approval. Double check here. This is a 45, 45, 90 triangle, right? Special right triangle, and it has the same proportions. The legs are equal, and if you multiply the leg by root 2, you get your hypotenuse there. Okay. There you go. I'll see you guys in the next one. Bye.